So you said Jedox has an OLAP server. What is OLAP?
Yeah, good question. So let's give you an overview. Here I have again my Excel file here with an explanation. In general, OLAP, online analytical processing. We are talking here about multidimensional data storage. So what does it mean, multidimensional? Let's say we have a relational database. You know this from Excel.
Yeah, so that looks familiar, just a table.
Right, yeah. So we have a month, we have customer, product, sales channel, some items we sold, and some sales we made with these items. So usually you would store it record set by record set in the Excel file. But in our OLAP database, we say that we need a sort of dimension where we have elements inside. So we call them elements. And they're looking more or less the same like our month values, but the difference is I only need 1 month only, and I can use it multiple times later in a so-called cube. So let's say we have hundreds of record sets, and each record set is representing a sales in a specific from a specific bike, and they all share the same month. So I have to store 100 times the same string 2016 or 5. And when I go later in my multidimensional data storage, I only need 2016-05 once to store, to find the storage area, to the right point in the database where my sales is saved. So you can say the column month, customer, product, and sales channel are more representing structure information. So
the structure information is what you mean with dimension?
Correct.
Okay.
Right. Yeah. So a month could be a dimension with many elements. So complete years and months, even days. And then when I have customers, I can also have a customer dimension where I have all my customers stored, my products, my sales channels. And when it comes to columns where I have values inside, it looks a little bit strange, right? Because the 15 should not become an element as a coordination point in our later so-called cube environment. Here, I want to find this value specifically in our database, and this will become not an element. This will become a cell. This will become a cell value. But the column header here gives me information. What measure is this? So this 15 is the amount of items sold. The 20,500 is the amount we get as a sales value. So I have 2 measures here. So I have to create a dimension. Let's call it measure. Could be also chart of accounts or whatever. So you can call it whatever you want. But inside this measure dimension, we have some elements representing exactly the measure later for our value information.
Okay, so it looks like what you have here, where you have a lot of redundancy in the relational data storage, it looks like you have more of these descriptive pieces as structure or predefined things, and that's why we don't see our numbers. And that's also because our numbers are going to change.
Correct.
Whereas this type of stuff, I'm never going to rename sales, or maybe I would, but chances are sales is going to keep that name, whereas numbers are always going to be changing and new ones are going to come in. And so it looks like that's why you're combining these things like items sold and sales into so-called measures.
Correct.
Okay.
Exactly. And the final goal is also to save storage data, because I only have to save a specific string like 2016-05 only once, for example, and also to shrink down the memory consumption and to make it faster, because this is also something unique in the OLAP environment. It's running completely in memory, so fast. Calculation is fast. Question is now, what can be calculated, because this is just structure we have.
So now we have this structure set up, but where are my numbers actually?
Right. I explained here that the numbers is the target is that we save this number somewhere. We have this the structure here. So let me scroll down here and I show you a nice little cube.
Okay, the famous cube.
Yeah, the famous cube I mentioned already. And let's take a look here. We have our customers presented by this dimension, the product, and the months. So this is a very simple cube. It's 3-dimensional.
Okay.
And if we take this cube and it's in memory, where is my data? My data is actually this little cell somewhere in the cube. But how can I find this little cell? I need coordinates, my elements from the dimensions that are pointing exactly at one cell somewhere in the cube. So for example, we have the bike is one element in the product dimension, and we have a month in the month dimension. So it's 2016-01 and the cross 150 silver. And the third dimension is now missing. My problem is I have only a 2-dimensional screen here and video. So the third dimension is customer. And then I can exactly locate a cell inside my cube by these 3 coordinates. Now the cool thing is cross 150 silver is only one time available, but I can store in the second month element a second value. And even in the same combination of month and bike, I can store another value to another customer. So I can save a lot of memory because I only have to create one bike and 1 month and 1 customer. But in the combination, I get 9 cells here and even more when I calculate the customers also. And we have here a different view on this. We call it slice.
Okay.
Because, as I said, the tricky part is we have only a 2-dimensional screen, video, sheet, and the cube has 3 dimensions. So we can take a look to our cell from a different point of views, and we can slice data out of it, and we can make it visible, and we show this also later with some cool features. And now imagine we are not limited to 3 dimensions.
Okay, that was going to be my next question. I have to say, it's a little hard to wrap my head around how this is a different kind of data saving than I'm used to, but it's apparently a lot more efficient, so...
Right, yeah, because it's in memory, and we are reusing data that is already there, like the elements, and we go also in a second view here and try to figure out how we can consolidate even fast data in this cube.